world's highest tides occur at the Bay of Fundy, and they're periodic in nature. At a dock in the bay, a maximum depth of water of 8 meters is at 4:30 a.m. 6 hours and 12 minutes later, at 10:42, it's at 2 meters. So in 6 hours, the depth changed 6 meters. This is enough information for us to graph. It's enough information for us to create some equations. So if we look at part A, it says write two sinusoidal equations, one in terms of sine and one in terms of cosine, to represent the depth of the water. In order to do that, we're going to first have to draw a picture of what's happening. So if I look right now, we're only given two pieces of information. We're given its depth at 4:30 a.m. at 8 meters, and its minimum depth of 2 meters at 10:42. So if I go to put this on my graph, we're going to label time down here, depth on our y-axis, and at 4:30 a.m., it's 8 meters. How am I going to write 4:30? I mean, I could write it just like this, 4:30, but mathematically, if we have to type this into our graphing calculator, I don't know how to put the two dots. I've tried hitting the decimal point really fast. It doesn't work. What should we do for 4:30? 4.5. Does that make sense mathematically? Instead of 4:30 to have 4.5? All right? And so at 4:30, we've got a depth of 8. 6 hours and 12 minutes later. So if this is 4.5, if that's 4.5, would you say that this seems reasonable for about 6 spacing-wise? They're not going to measure it with a ruler to see if you're perfect, but we do need to be somewhat accurate with our scale. What time do I put there? $10.42? No. If 4:30 is 4.5, how do we figure out what 1042 would be as a decimal? Write 10 point something really messy so the teacher has no idea what you wrote and hope that it's right. Well, 30 you somehow got as a half. Why is 30 a half? Because there's 60 minutes. 30 out of 60 is a half. So easy that you did it mental math. But could you apply the same logic to 42 minutes? 42 out of 60 is 7 out of 10, which is 0.7. 10.7, we're going to be at 2 meters. When is it going to be at 8 meters again? Boy, my line is really not very straight today. Do we agree this same distance, it's going to be back at 8 meters again? How do I figure out that this is going to be 16.9? Just a lucky guess? Okay. This distance here is how much? 6.2 hours. Another 6.2 hours will get you back to the maximum. If it's periodic in nature, it's symmetrical. Where's my center line going to be other than it's in the middle? Yeah, okay. That's fine. But what value is in the middle? Y equals 5. Can you see that I've got one period here from 4.5 to 16.9? That if we added marks here and here, that's where it would be on your center line? And we can draw our graph. Can you label these points in between? If this is 6.2, add 3.1, so 7.6. Add 3.1, 13.8. And once you have the graph, you can work backwards from the graph to find your equation. And we can write an equation in terms of sine and one in terms of cos. So if I wanted to write one in terms of sine, what's my amplitude? Think about dab C here. My amplitude is 3. My center line is at 5. My b value is always 2 pi over my period. What's the period in this situation? 12.4. 6.2 plus 6.2. And so I can write that my amplitude is 3. If I choose sine, my b value is 2 pi over 12.4. My d value is plus 5. The only thing I need to figure out is where does a sine graph start? A sine graph starts in the middle going up. Here's a point in the middle going up. What kind of transformation would that be? We'd have to go to the right, 13.8. Can you see there's another in the middle? Whoa. Another in the middle going up right there? What would this point be? $1.4. Right? He figured out that in between the ticky marks is 3.1, subtracted 3.1. So another sine one you could have written is exactly the same of everything except saying I'm only going to translate 1.4 to the right. If we wanted to write a cos graph, the amplitude's still 3. The b value is still going to be 2 pi over 12.4. The center line's still at plus 5. Where does a cos graph start? At a maximum. Right? That's shifted 4.5 to the right. So we can write, and you know what, if you wanted to, could you find another cos graph? Yes. And another one, and like, there's a million right answers, infinite right answers. Okay, usually we just try to find whichever is the maximum that's closest. Right? You could also start at a minimum. If you wanted to start at a minimum, how would that change your equation? You'd have a negative 3 in front rather than a positive 3. Or if you wanted to start in the middle going down, it'd be a sine graph that would be negative. Okay? On a question like this where it says write 2 sinusoidal equations, 1 sine and 1 cosine, you get choice. They'll accept any right answer as long as it matches up. Okay? If you're feeling extraordinarily frustrated with your math teacher, right? You could figure out something in the 3000s just to make me check. Right? Chances are you're going to make a mistake, but if you really want, you're like, oh, I hate how much homework Mr. JR is giving. I'm going to make him work this one out. You could figure one out way over there if you wanted to. And then part B here, estimate the depth at 130. Again, it just says estimate, so we don't have to get a right answer. Where would 130 be on here? Is 1:30, and did it say 1:30 p.m.? 13.5. Right? Because this 1:30 would be a.m. 13.5 would be 1:30 p.m. Right? And of course, this graph is wonderful. Here we go. What do you say? Estimate about 3.2. Yeah. If you wanted to find it exactly, if you're feeling somewhat unsure about my abilities to draw accurately at this moment, and you wanted to find it out exactly, well, you could take one of your equations, any one of them, they'll all be exactly the same. Type it into your calculator, set the window so that it matches up, and then plug in 13.5 and find out what it is exactly. It'd be hilarious if it was exactly 3.2. So what I'd like you to do right now for practice is you've already done the one practice question at the bottom on the Ferris wheel. So now you can do the other practice question on the tides. And then out of your textbook, there's some good questions as well on page 548. You can practice the ones, any questions from 3 to 9.